Okay, Paul here, and today on the bench we have a weird project. Hopefully we can get it fixed. This is a Cutty Sark bar display for Scots whiskey. It has these waves in this case, and then above it is a ship that sits on a plexiglass platform, and it rocks inside the waves. It moves back and forth as the waves go. Well, the mechanism that moves it is broken. So I just took this out of the box, my first look at the case, and it's got a little bit of nicks, but nothing major. Nice shape. The box is in good shape, and it's made out of plexiglass. So I'm going to go ahead and unpack it. It's still got packaging in here, and we'll take a look at it. Be right back. Okay, this is the inside, and this is the wave maker here that turns around, and this sits in here like so, and it goes down in these grooves. There's one in the front, one in the back, and it sits on those wheels like this, and as the wheels, no, I didn't get it in there right, but as the wheels turn, yeah, it turns like this, side to side and front to back, and it makes the ship rock inside here. Now, I don't have the ship. The customer didn't send that. We get this going, and I'll definitely ask the customer to provide a full picture of the ship with the display so you can see what it looks like. But right now, we want to at least get the unit working. So this is the part that's not working. The fan spins, but this doesn't turn, and this is part of the gearbox here, assembly. It's got an Allen wrench there, and that shaft there is not turning, but the motor is running, so it's something in the gearbox, and you see it's riveted. So let me go ahead and take this out, and we'll go ahead and drill out those rivets and take a look at what's inside. So let me get that out, and we'll take a look at it, and then we will continue. Okay, I got the display out. I haven't disconnected it yet from the line. It is connected in parallel, so it runs on 120 volts, and it's in parallel with this fluorescent light, which I'm assuming works. It's got its own starter. So these are crimp-on connectors. I'm gonna go ahead and just cut these off, and when I put it back together, I'll just solder them and put shrink wrap. Be much better connection than these. These could get hot as they get older. So let me just try to uncrimp these and unscrew them. They've been crimped pretty hard. I might have to cut them off. Anyway, that way we can separate the motor and work just on it. Be back. Okay, I've got the motor plugged in and on my Variac, and I'm just running on 87 volts right now. And it's turning. The shaft is turning, but you can hear that clicking sound, and I can hold the shaft and stop it from turning, yet the motor is still turning. Actually, it's got a lot of torque. I don't see what the problem is. I can barely hold it, but I can hold it, so there is something going on. And this is a synchronous motor. So it's synchronized to 6 RPM, it looks like. And it's got the signature of the person who inspected it. And it's got a clip that holds the motor in place. So I'm going to go ahead and disconnect the power, and we'll gently take the motor off and see if we can see an issue inside the case. Give me a second to do that. Okay, I got the motor out, and this is the motor shaft here, and it turns. This is just a insert on the shaft. It's got a little bit of dirt on it, so we'll clean it up. That just sits in there in the part that turns. Sits down in there. And then this is the gear box. And you see there is some oil, and there's some oil inside, but they're plastic gears, and that was setting at that orientation. This little arm here will only swing from there to there, so I gotta figure out what that does. And this is the part that the motor turns, and you notice it is turning these two gears here. Now if I drill out these three rivets, and turn this around, if I drill out these three rivets here, this one, and this one, this cover will come off, but this is the pin that holds this gear in place. And of course underneath it, we have another gear down in there on the very bottom, and one here and one here. And I would imagine they're under this round plate. So I don't know, that looks like that separates somehow, probably turns or something, but that gear is going to fall out if I do that. I'm going to have to do that though at some point. I'm not sure exactly why there's not enough torque in here to move the ship. When I was holding it just at 87 volts, it was pretty hard to stop that motor from turning. This is the clip that holds the motor in. I'm going to gently bring the voltage up with the motor out here and see what happens. Let's see when it starts turning and get the light closer to you, to that so you can see it better. Okay. And let's see when that motor starts turning. I'm at 38 volts now. $72. There it goes. It's starting to turn. Well, I'm up to 90 volts, so it's a vibration synchronous motor, so without pressure it don't want to turn. But I can feel it. The motor's fine. It's got plenty of magnetic flux in there. I noticed that some of that oil is in there is kind of coagulated. See it on the bottom there? See how it turned to goo underneath those two gears at the 11 o'clock position there. And it's hard for me to get the light there in the camera, but yeah, you can see it in there. See it under there? I'm going to try to clean all that out and put some new oil in there. It actually should have some grease. Let me see what that is and get some of that out of there. Yeah, it's grease. If I can get this apart, it's kind of gummy. It's sticky and gooey. I might be able to clean it out and put some new white lithium grease in there, which should help. Let's see what I can do. Maybe I can clean it out without actually taking it apart, because the only place that needs the grease is on the T and on the shaft. Don't really need all that gum in there. That seems to be very gummy. And see inside, I don't know if you can see inside. See inside that gear there? It's like dirt inside the spline, between the splines. That will make it more likely to slip, because this little gear that runs in there has got very fine teeth for that bottom one, but as they come up, as it's turning, that dirt stops the gear from meshing really well. So that's an issue. So we definitely need a good cleaning out. I hate to take it apart because all of these holes are holding the shafts, this one, and I imagine these are underneath this round plate. So taking it apart and then trying to get them all lined back up again is more of a job for a watchmaker than for an electronics person. But I'm going to do my best. I do motors, obviously you see them on my YouTube channel, phonograph motors and things of this nature. And I do know that when grease gets old, it turns to glue, And I think that's probably 90% of our problem. And then there's dust and dirt in the teeth, which I can clean out. So let me work on this, and then we'll take another look at it. Okay, I got it back together, and I haven't done nothing to it. I just want to make sure that I could line it back up, and it's running again. But you can still hear the motor. And the gears are meshing okay, except like I said, there's some dirt in there. But that motor is making a really weird sound. It's probably normal, but it's probably also old. And so we're gonna try to fix that. Looks like this is a plastic sticker here, a seal that they put on here. This round plastic sticker with the label. And it covers these holes, which I would imagine were the original oil holes that they used after they put it together. You can see the shafts there, and there's probably one under this. And then there's this one here, looks like an oil hole. It may be a shaft for a gear, but I don't see no gear in there. But it's turning. It just doesn't have the torque it should have. There's another shaft there. So if I take this apart, those gears are just gonna all fall out. And that would be a disaster for me to have to figure out how to get them in there. I just don't know, because this is done on an assembly line, and these people knew exactly what they were doing. They had the specifications in front of them, the documentation, everything they needed. And it might have even been done, some of it, on a machine, because these are riveted, and they don't look like they're hand rivets. They look like they're machined rivets. So anyway, let me go ahead and clean it out. That's the first thing. And hopefully that'll make a big difference. Okay, I'm going to try to show you what I've been doing to clean it out. First, I sprayed some cleaner in there, and you see on the napkin here where I got some of this out. This coming out of this gear. And so if I turn this gear, the motor gear here, it turns the other gears, and I'm looking at them. It's hard to keep it under the camera, I apologize. I'm looking at them and see the dirt. I turn it enough to get some of that out of there. And turn it a little more. And you see it in the teeth there. I don't know if you can see that, but I can't turn that gear directly because it's geared down in speed, and if I turn it, I'm just forcing it. You can't do that. Yeah. Try to hold that there and that there. See it in there? It was two of them. I got a whole lot out of it. But that's where that causes pressure between the teeth that intersect with that. And that pressure could be enough to make the gears slip by each other. Between that and the dried up glue. So that's what you do. You just keep going around. Get as much of that out of there as you can. Now, I already sprayed in here and dissolved a lot of the glue. You see it's all out from under there. All that old grease. And of course, I'll spray it again after I get these gears cleaned. And then let it dry. I'll rinse it out with alcohol, which will dry it out, and then put new grease and oil back in once the alcohol dries. But this is the only thing I can do. Since it's plastic gears, I don't want to take the risk of taking this apart. See all that coming out of there? And I'm just being very gentle on the gears because you don't want to hurt them. You just want to get between them, the teeth. I hope you can hear me. I have to wear a mask because the chemical I'm using is pretty strong. I may turn up the first part of the video, in which case it'll probably be a little loud, and then when you get here you'll have to turn the volume back up to hear me. But you get an idea just watching the video. Is that a little better? I'm trying to get it where you can see, but I can still get in there with my hand. That's why I'm using this screwdriver. So you're probably wondering what chemical I use for this. Well, it's kind of expensive, but it's good stuff. It's what we use to clean contacts and volume controls and things like that in electronics. This is MG. Let me get that under the light. This MG electro-solve contact cleaner. It's really good stuff, but I'm supposed to use it in a well-ventilated area, and where I'm at is not the most ventilated area. It's highly flammable, and I got a heater going right behind me. Okay, I think I got most of it out of there. There's still some liquefied goo in there, but it's, get back over here. It's not that bad. See it down in there? I got most of that out. It's almost all gone, actually. This is turning real easy now. So the next thing is flush it really good with alcohol and get all that old stuff out. And I'm hoping that this does it, that there's no damaged teeth. But I don't see any on this gear here that I'm turning. Everything looks fine. But you know, over age, since these are plastic, turning on a metal shaft, over time, the hole that the shaft goes through wears bigger and bigger. And when it wears bigger, the gears can wobble. And when the gears wobble, they can pull away from the one that they're supposed to be in under pressure. You know, this doesn't seem to have a lot of play, but you know, a few thousandths of an inch can make a big difference on a tooth. Especially on that, these back here. See, there's one in here, which is this one here, and then there's this one here. Oh, there's some junk. What is that? You see that in there? Let's give that a shot. A little bit of it. Let's keep going. We already did that last gear. We're working on this second gear now, which has 2 gears on it. See, if I try to turn it from there, I can't. It's too much pressure. I've got to turn it from the one the motor turns. One more there. I can't get in there with the screwdriver to do that, so I'm just going to use spray when it's a really bad spot like that. So we just got to hope that these plastic gears are not deformed. Another problem with plastic is over time they shrink. You know, just like rubber, plastic shrinks. And when it shrinks, it's not going to make as tight of a fit. Okay, that looks pretty good. And everything in here looks pretty good. The gear in the back, I been around enough. I don't think I see much on it. This one down here, which is back there. I can't show it and turn it at the same time. Okay. Okay, I think we broke everything up. It looks good. I think we're fine. So now, I'm going to put some alcohol in there and dissolve it even more. I'm going to get a napkin here, and you can see the runoff. I'm just going to put it over that napkin. Okay. And I got a plastic sheet under it, a packing envelope that I cut open. They make great surfaces. They push in and they protect other things. Okay, let's put some alcohol in there. Some liquid gold. And we want to shake that around. And then pour it out. Look at that. You see how good that does? Look at all this, look at the stuff we got out of there, the dirt. And we'll do that one more time. Get some more liquid gold. Let me move the light. It's kind of a... Okay, that's coming out pretty clean now. But you see all that? Look at that. You see all that stuff running around? That's all dried up grease and dirt. That's the best I can do is clean it out. See that?
Let me try one more time. Okay, it's coming out a lot cleaner now. So that's good. That's the best we can do there. Let me get this out of here. Let me get a Q-tip and get some of that out of the bottom there. Yeah, apparently that was, see that pin hole there? It goes right through the bottom. That's under this sticker. Apparently there's holes like that one and this one here. That one's under this metal, and then there's that one. And those are places to oil before they put that sticker on it to hold the oil in there. Okay, that's good. You see, it's pretty clean. A little bit of grease, but not bad. But we got all that dirt out of it. Let me go fishing around. I don't want to get no little hairs in there. Sorry for moving the camera there. Okay, I'm going to dry this up a little. Normally I wouldn't mind putting a lot of heat in there to dry that alcohol up. Alcohol will dry real fast anyway. But dry some of it up. I put a little bit of heat in there. I don't want to overheat it because they're plastic. So I'll let my heating gun air out a little bit. There we go. And get some of the out of the case here. I don't want to do too much. That's good enough for that. And I'll just let it dry out good before we put new oil and grease in it. Now the motor. The motor has a similar issue. It has old grease on it, so I'm going to get that off. We don't need grease on the motor, on the ring. It wouldn't hurt it. That's why they got this plastic on here. And let's look in there. There's some, see the dirt and debris in there. On that. So I'll clean that off. And let's get some dirt in there. I'm going to have to spray it to get it off. Let's put this over here. Yeah, that's clean. Now let's look at the motor itself. There's a lot of gunk in the bottom there that's dried up. Let's see if I can get some out so you can see it. Yeah. Looks like this ring comes out. I don't really want to take it out though. I don't know what's under it. Yeah, it's like a magnet. It is a magnet. I don't see anything under it. Let me see. Maybe we can go ahead and take it out and clean it a little better. Okay. There's a magnet and a bushing. Yeah, get that out of there. Actually, okay, that went with the hump up, and that went, oh, it goes, sits in there. Okay, I see where it goes. So we can clean that out a little better. You see the dirt now? Then we'll re-grease this. Let me get a Q-tip. Okay, and you know, people ask from time to time, how do you know what to grease and what to oil? Well, that's a good question. The best rule of thumb is anything that turns, you grease. And oil, sorry, anything that turns, you oil. Anything that slides by something else, you grease. Okay, so this is basically just a coil, and this is the magnet here. See? And so the coil makes a magnetic field that this magnet interacts with, and it pushes this magnet around in a circle. And as it's turning, it's vibrating, which causes the inner shaft to turn with it, that plastic thing. But that's where the okay, so this magnet turns, right? And this vibrates and turns with it. But when you stop it and you hold it, this can stop and the magnet can still turn. And that's by design, so that you don't ruin the teeth on the gears. I'll clean that magnet up better. Put dirt right back on it. Okay, I got it. Almost. Check that again. Right. That's good. So that's why you can hold it with your hand and stop it from turning, because it's got it's sort of like a fail-safe, right? It's just, that's what they mean by synchronous motor. I'm going to move that over there where it don't get in any alcohol. And this is just a plastic washer here. That's all it is. See? And it's rounded on the top, flat on the bottom. It's just a pivot point. This like mountaintop edge around it is very narrow, very thin. So this sits flat on the bottom where it's not likely to turn, but the top is so small of a contact on this that it allows this to slide and turn. Anyway, back to what I was saying. You put oil on things that turn. You put grease on things that slide. So, you know, now that's a good rule of thumb. Now on things like teat, you can put a little bit of grease because that helps them stay together. This is a little spot there where it was molded. Let's get some dirt in it. Not bad though. That's not going to hurt anything. So like a molded edge. Spray it. That's about the best that's going to go. Okay, so that sits inside, and this sits on top. So I got to clean this. This we can do. This is just a magnet, so we can just clean it with alcohol. And so this slides on that. So this would need grease so that this can slide and turn. So things that slide, you grease. Things that turn on a shaft, you oil. And gears, you oil the shafts, but you can put oil or grease on the gear. You don't want to put a lot of grease because you don't want dirt in the teeth, right? So on those, you just use some oil, and I use good oil, so it's got a good viscosity. It'll last a long time, but it's not too thick that it's going to attract dust and dirt and cause problems. It took years for this to get to this condition. So okay, so let's go ahead and put this back together. This is all cleaned out really nice, and I see that looks like another plastic ring. No, that's not plastic, it's just the metal. Still got a little bit in there, but that's grease, and that's so, again, like I said, so this stuff can slide, and then you see where the ring was. Let me get another Q-tip and see if get some more of that out of there. No, that's it. That's just the discoloration of the metal. See? A little bit, but not much. These contacts here, just, again, they slide. Well, they don't slide, they lock into the mechanism. Okay, let's go ahead and put some grease in. And I used good white lithium, multi-purpose white lithium grease. And this is good stuff. It's expensive. It's dielectric, heavy duty, food grade. It's very clean, and it'll stay clean. I need to order another tube of this stuff, but you see it? It's very clean. So we'll put that on a little bit on this. I'm thinking it slides top and bottom to give it the ability to not bind up. So we'll put that in there. And then this, we'll put some on here. And on the inside. Center that. And that sits on it. Of course, I dropped the clipping. And let's center it under there. Yep, it's centered. So that turns easy now. See how that turns? So we'll turn it and let it grease up good in there. You don't need a lot. You put too much grease, you're going to make it gum up again. It's just too much. So you just want it to stay lubricated. And that grease will keep it lubricated a very long time.
Okay, I figured before I put this thing together permanently, I might as well show you how this asynchronous motor works. It has a coil, and that's all. The current goes through the coil and inducts a magnetic field in one direction around the coil. This way, around the coil. Comes through and around, And that magnetic field interacts with this magnet, this permanent magnet, and makes the permanent magnet turn. So that's how it works. That's all there is to it. And this had paper tape around it, and I figured I better take it out and clean all the excess oil out of it because it had way too much oil in here. I think that was most of its problem, was just too much oil making it slip, but also it needed to be cleaned. It was so dirty, and the oil had turned to glue. So I'm going to just touch up this again, clean it a little more, put a little more grease on it, and because I see it did pick up a little more dirt, and then reassemble it. But I wanted to take an opportunity to show you how these motors work, what they actually consist of. Okay, there's two issues with the motor. It's actually the motor that's a problem, not the gears. If I try to put this clip on, it stops it. The first issue was there's wear. Well, I'll show you. Let me pause this. Okay, The first issue is there's a ring of wear right around here. You see that black ring that goes around? That's actually worn into the metal case. And what that's from is the magnet here. Okay, two reasons. One, that plastic disc that sits in the magnet is recessed up in it. See that? I don't know if you can see that in the light. That's because that plastic shrunk. And so it's supposed to stick out a smidgen below the magnet. And the reason being is that way the magnet doesn't rub on the bottom of the case. Okay, so to fix that problem, I put that little spacer in there. That's about, I don't know, maybe 1/32 thick. 1/32 of an inch maybe thick. I didn't mic it or anything. It's just a small little tiny washer. And it's underneath this plastic, which actually helps because it's actually less friction space than the original, because now the whole plastic isn't rubbing. Actually, that tip of that plastic looks like it sticks down below there just a little, but again, it shrunk. So the magnet was dropping and rubbing down there. Okay, that's one issue. That raised the mechanism, the motor mechanism, away from the actual base down there where it was rubbing, which was causing most of the problem. You see where it was rubbing. Okay, now the problem, if I take this out, now the problem is this piece, which has this ring on it, see it, which has this ring of plastic around it, is hitting on that gear because we're lifting it up here. So it's when you put the clip on, it pushes on that gear. And when it pushes on that gear, it puts too much strain on the motor, and then it just slips. This turns, but this doesn't, and hence the clicking sound. That's what the clicking sound is from. This is supposed to turn with the motor. Okay, that turns with this motor. When you hear that clicking sound, which I can't do with one hand, let me try it again. That's that slipping. That's what's making the clicking sound. That's supposed to turn with it, see? It grabs into those little teeth in here, grab into the little divots in the side of this ring. And so that's what makes it stay with the motor and turn. And this, of course, is the gear that turns the other gears. So if this slips, then nothing turns, right? So the next thing I got to figure out is, okay, that seemed to work for that, to get that off the bottom. I don't know if it's a little less or a little more rubbing force, but it had a lot of torque, so I think it's fine there. But the next issue is when you put this clamp on, it's pushing this down so tight that this is pushing down on those gears, and again, it won't turn. So what we got to figure out here is how to keep this clamp from pushing the motor down so hard. My thought would be maybe run a piece of wire around here so that it's under the edge of this, or maybe a piece of flat, I got some aluminum tape actually, that might do better. But something to hold this up so that when you put the clamp on, it's not smashing it down into the gears. And that's the next problem. I mean, that's what's causing the issue, is that magnet getting grabbed, is dropping down. And when it drops down, way down there, it slips off this. And we got to figure out how to keep it from dropping down in that motor shaft. Okay, excuse me. Okay, I've tried everything I know. I tried putting a small washer under here that's just under the center of this. I tried a bigger washer that's just under the outer ring, and then I tried one that was under the magnet, and of course that didn't work at all. But the friction down there is what's causing the issue. And what happens is this part here, let me stick it on a napkin or something. Okay. This part here, the magnet drops. And when the magnet drops, this comes up. And when this comes up, it just slips. I was thinking of putting something on the top, but I can't because of those two fins that stick out the side are needed to switch the mechanism in there, depending on which way the motor kicks off when you first plug it in. That depends on what part of the AC cycle it's on. If it's on one side, it'll turn one way, the other will turn the other. It doesn't really matter as long as it turns, right? So that's what those wings are for. My last ditch option, because these little teeth here are fine in here, but the part that they groove into here is just worn away and this just slips. I dried it off and tried that. It's better, but it still slips. The slippage is so that if somebody was to grab a hold of the ship and stop it, it doesn't do damage inside. But since it stops the motor anyway, if you stop the wheels from turning, I'm thinking that it would be better just to not even have this. I can't reproduce this, and I can't get a motor that'll work with that. It's just not going to happen. This core is designed with these metal pins here. Most of the time when you put this together and plug it in, it will not spin. It will not spin until these metal tabs here, these 4 metal tabs, fill in these gaps in here. They go in these gaps, and that makes like an iron core for the magnet for the, actually it makes like a stator for the motor basically. This is the stator coil, and that like acts like a stator, isolating the armature, which would be this magnet, from the stator, and creating the torque that's needed to turn it. Since this thing just will not stay grabbed in there, I was thinking of doing a test, my last possible test before I give up, because I have so many projects backed up. I have to either put this on the table or just drop it. But my last test is hot glue it. Just hot glue it into the magnet so that it can't slip. And, you know, and if somebody is crazy enough to just grab a hold of the ship and stop it, most likely they'll just stop the magnet from turning, and it's not going to do much damage to the coil. Basically, the coil runs on, when it's running, between 1 and 2 milliamps. 10 and 20 milliamps. And when there's no, when it's not running, when the other metal tabs are not in here, it's 30 milliamps. So, which it is now, see, 0.03 amps. So that's 30 milliamps. And that's not going to hurt it. That's because it's not turning. If it was turning, the current would drop down to 10 to 20 milliamps, probably around 18, 15. It shows 10 on this because this thing is not that accurate. I could get a more accurate reading with my amp meter, but it really doesn't matter. I'm thinking that's the only other thing I can do is hot glue that in. If it works, great. And you just have to be delicate with it. I mean, it's old and it's worn. And it's plastic, so there's not much you can do. You know, I don't know how to get another motor that would work for this. It would have to be a DC motor. I can look around, but I would have to, basically I'd be redoing this entire case. I have to find a DC motor that we could control to rectify a circuit. You're talking a lot of money, a lot of engineering. And it would have to be riveted in, and the shaft would have to be the correct size, and all this gearbox would be eliminated because there's no way to get a motor that would work with that. So that's my feedback to the customer. I'm going to try that, and if that don't work, I'm going to upload this video, let him look at it, and then we'll talk and decide what the next options are. I can always peel off the glue if need be, but I don't think I think that's the best chance. if we can keep these two pieces from not sliding by each other, then this will turn the gear. It's not stripping. The gears are not stripped at all. It's just this is slips. See how it slips? See what it's doing? It shouldn't slip like that. Every once in a while it'll grab, and when it grabs, it'll turn it, see? But then it just vibrates loose and it starts slipping again. And I can't get it to stay grabbed, so the only way is glue it. I'm going to try that next. I'm not going to use epoxy. I'm just going to use hot glue because I can take it off. I mean, if I wanted it permanent, I'd epoxy the dang thing and it would definitely stay together. But that would be a last ditch, because if that don't work, then it's trash. But maybe the hot glue will tell us if that's even an option. So anyway, thanks for watching the video. I hope you found it interesting. At least maybe you learned a little bit about these kind of motors and how they work. And I'm going to try my best to get this working for the customer. Thanks for watching. Okay, preliminary test with hot glue. It's working. And it's got pressure. And it's drawing, says 10 milliamps, probably drawing 0.9, 0.8, 0.0, yeah, 9 or 8, maybe a little more, because it seems to jump from 1 to 2, like I was saying before. So it could be, jumping like 0.09 or 9 milliamps and jumping up to 11 and then back down to 9. That's fine, and it's working. Gluing that stopped it from slipping. Now, what I would suggest is if it ever did let go, go ahead and take, it would be because the glue let go of the magnet. The magnet is metal. So if it ever did let go, if the glue ever did break free, which probably could happen, what I would do is you just take that little clip off there, the motor comes apart, take that little plastic thing out, scrape the glue off around the inside of the part that goes into the magnet, and put some epoxy on it, and that'll never let go. But I wouldn't do that unless it's a last resort. Right now, it's functioning. I've unplugged it and plugged it back in. Let's see if I can get it. It's hard to unplug this with one hand. Okay, plug it back in, starts right up, unplug it, plug it back in, starts right up, unplug it, plug it back in, starts right up. So I think we're good. And it's got the torque it needs to move the ship. Do not grab the ship and stop it from turning. Do not grab this and stop it from turning, because if you do, you could hurt the gears now. That was a fail-safe mechanism, but it wore out, and there's no way to recreate it. So there we are. But we got it, and it'll work, and that's all that matters, right? So I appreciate your time. I hope you've enjoyed this video. If you have, give it a thumbs up, and we'll talk to you next time. Okay, there we have it back in its case, and with the switch on here, shut it off, turn it on, and I used wire caps instead of soldering and shrink wrap. That way, if it ever has to be worked on again, you can take the motor out without having a bigger problem of having to cut the wires. I'm also going to put a wire tie around here, and so that this line cord doesn't get pulled, and just tie it together so it can't go through out there. And that should be fine. Let's see, the plexiglass. I'm not sure which side this goes up. I guess this side goes up. It's got foam on it, so I would imagine it goes up. Let's see what that does. There it is. Look at that. Once the ship is on there, see how it moves. Of course, the weight of the ship would hold it down. It's just not dropping down because there's no weight on it. Yeah. Let's put a little weight on it. Yeah. Look at that. That's cool. Note to the owner, if you could, please send me a picture or a couple pictures or short video of the ship, this whole thing assembled and going. I would love to see it, and I could add it to this video. If it's a small video, I'll add it to this video. If it's just some pictures, I can definitely use it for this video, and I would appreciate that. All right, thank you. Thanks for watching. Hope you've enjoyed it.